So here's a question that we can solve that's related to average velocity and time and running some crazy thing. My gym teacher in high school used to make us run suicides all the time, and I hated them, so I've remembered them really well, but they're not enjoyable. So the question is, if your coach has you run suicides in the gym, which is running 1/4 of the way across, coming back halfway across and back, 3/4 of the way across and back, all the way across and back. We have how long the gym is. We can run at a constant speed, so we'll assume that we're running constant speed the whole time and there's no turnaround time. And our constant speed is 4 meters per second. So then the question is, find your average velocity and find how long it takes to do one of these things. So the first thing to do, remember I said starting a problem, first thing, sketch it. This one, a sketch will help, because I've got my gym, so I know the gym is 50 meters long, okay? What I'm going to have to do in this gym is I start here and I run 1/4 of the way across and back, and then halfway across and back, and 3/4 of the way across and back, and all the way across and back. Whew, that's what I have to do. All right, so I start here at one side of the gym, back and forth, back and forth, back and forth, and there. So first question, we've got 50 meters in. Oh, I should write that I'm running at 4 meters per second. 4 meters per second. All right, so I'm running at 4 meters per second. It's 50 meters going back and forth like that. Find your average velocity. Okay. This is a really simple question. And this looks like a very complicated description and a complicated diagram. Do you see why this is a very simple question? Average velocity, so your V average, so Vx average, and I'm actually going to draw, this is a vector symbol. I'm going to draw a vector symbol on top of it so I remember that I'm talking about velocity and not speed. Okay? So my average velocity is delta x over delta t. Okay? Delta x over delta t, this is a change in position. So final position minus initial position over delta t. I don't know what delta t is, but I know that my final position is the same as my initial position. So this is 0. Simple. I've got average velocity. So my average velocity is 0. That's easy. And now the time to complete one suicide. So the time, okay. I know my average speed. I should have set this up before. So known speed, Vx is 4 meters per second. I know, well, I didn't actually know what the distance is. And then my unknowns, this average velocity. I also want to find the time. How can I find the time? Well, I know my speed. I can figure out what the distance is, and if I do that, I know that my speed, change in position over change in time, so this will be my average speed, and that tells me that my change in time, if I multiply both sides by change in time will go here. If I divide both sides by average velocity, that'll come down here. So delta x over the average. So the time, delta x, well, let's see. This is 50, so this one is 37.5, this one is 25, and this one is 12.5 meters, one direction. So 12.5 plus 12.5, that's 25. 25 and 25, so I got 25 meters here, plus 25 and 25, so it's 50 meters here. 37.5 plus 37.5, that's 75 meters, and 50 and 50 is 100. So if I add all those together, 100, 250, so 250 meters. You know what? Did you see? I make errors sometimes. I shouldn't have used delta x here. Delta x is a change in position. I should have used d as my description. So the average velocity is d over change in time. So 250 meters, that's the d, it's not the change in x. Okay, 250 meters divided by the average, which is 4 meters per second. And that gives me meters divided by meters, those cancel. So I've got 1 over seconds in the bottom. So I'm going to have something in seconds. So 250 divided by 4 seconds. And you can put that into your calculator to figure out what that answer is.